Good morning to all of you. Welcome to Young-Minds Prep Physics channel. Today we discuss about the key and solutions of JEE Mains examination conducted on 2nd April 2025 in shift 2nd session. Okay. First we discuss about questions asked from first year concepts. Okay. Then we go to the questions asked from second year concepts. Okay. So first question: if mu naught epsilon naught are the permeability and permittivity of free space respectively, then the dimensions of 1 by mu naught into epsilon naught is. You see, from our previous knowledge, what is that? The electromagnetic wave is nothing but a resultant of electric and magnetic fields are varying with respect to time. Okay, so we know that, okay, what is that? 1 by mu naught epsilon naught under root is equal to what? C. Here C is equal to what? Velocity of light. Velocity of light. So square on both sides. That implies 1 by mu naught epsilon naught is equal to what? Square of velocity. So 1 by mu naught epsilon naught equal to what? C square, velocity. Velocity is equal to what? Distance by time. Distance is unit of length. Length is represented by L. Time is represented by T. Is nothing but what I said, whole square. So the answer is what? L square by T square. So this is the answer for this question. Okay, the second question: match list 1 with list 2. List 1 comprising some physical quantities, list 2 given their physical units. Okay, SI units. Okay, first one is what? First one is heat capacity. Heat capacity. We know the heat capacity of a body is defined as the amount of heat required. The amount of heat required to raise the temperature of a body to unit Celsius. That means delta T. H is equal to delta Q by delta T. Here delta Q is equal to what? Heat is a kind of energy. It is nothing but joule per temperature is Kelvin. So what is unit? Joule per Kelvin. So first one is what? Second one. Next B. Specific heat capacity. Specific heat capacity. Okay, it is defined as heat capacity per unit mass of a given substance. So H is equal to already getting joule per Kelvin. Okay, mass kilogram by kg. So joule per Kelvin per kilogram. So second one is 3. This is. Next, third one, C is equal to latent heat. What is that? Latent heat. L is equal to what? Q is equal to ml. Q is equal to m into L. L is equal to what? Q by m. That means the amount of heat required to change the phase of a matter. Okay, at constant temperature. It is depends on its mass. So L is equal to what? Q by m. Q is equal to what? Joule. Mass is equal to kilogram. So joule per kg means what? Joule per kilogram. Joule per kilogram. In this one, this is the correct option. Next, thermal capacity. Thermal capacity. Okay, what is the thermal capacity? It is represented by K. The thermal capacity of a body it depends on different factors actually. Okay, how allow the given body to flow of heat through it. Okay, so the thermal capacity, that means heat is flow from one end to another end. Okay, of a rod. When you take you want to calculate thermal capacity, Q is equal to some constant. That constant is thermal capacity into cross sectional area into delta theta. Delta theta is the difference in temperature between the two ends of a rod. Okay, that is taken, that is solid. Okay, into T by L. Okay, so here T is the time taken to reach the heat. That means flow of temperature from one end to another end, and L is the length of the rod. So K is equal to what? Here K is the thermal capacity of that substance. K is equal to Q into L by A into delta theta into time T. Delta theta into time T. So Q is equal to what? Joule meter. Length is the meter. By area is equal to what? Meter square into delta theta. It is nothing but temperature. It is nothing but Kelvin into second. So 1 m is cancelled. Therefore, K is equal to what? Joule per meter. 1 m is remaining. So joule per meter per Kelvin per second. So fourth one is the option for it. Okay, the third question. A sportsman run around a circular track of radius r. So this is a circular track of radius r such that he travels the path AB AB. That means he travels the path AB, B to A, then AB. Okay. The distance travel and displacement respectively are. So first one is what? Distance. What is the distance definition? Distance is the total length of the path traveled by a person. So here the person is travel, okay, the path AB. That means what? A to B, then after B to A, finally reaches to B. So first means what? A to B, then B to A. You know, A to B is the length of the path is equal to what? Pi r. Okay. Next B to A plus pi r, then A to B plus pi r is equal to what? 3 pi r is the distance traveled by the person in entire journey AB. Next one is called displacement. Displacement. What is displacement? Displacement is the shortest distance between initial and final point. You have to say A to B, B to A, then B. That means A is the initial position, B is the final position. So the shortest distance between initial and final is nothing but this is r. This is equal to r. So displacement equal to what? R plus r is equal to what? To r. This is the answer for this question. The fourth question. A body of mass 1 kg is suspended with the help of two strings. So this is 1 kg body which is suspended with the help of two strings. Okay, making an angles. This is the first string. This is the second string. Making an angle 60 and 30 with respect to the horizontal. Okay. The magnitude of tension T1 and T2 are respectively. Find tension T1 and T2. Okay, this is asking. You have to see this is the body is experiencing three forces. Okay, according to Newton's laws of motion, you can say the whole system. First, we draw the free body diagram. So this is the first body of mass 1 kg. It is experiencing two forces. One is called this is T2. Okay, this is what I said T1, isn't it? And third one is called its weight is act vertically downward in direction. It is nothing but what? Mg. Okay. Okay, the body is in equilibrium. That means what? This is the tension is a force which is resolved into two components. One is along the vertical and one is along the horizontal. So this is what? T1 according to given figure, this is equal to what? 60 degrees. So which is equal to what? T1 cos 60 because it is adjacent side. So obviously this is what? T1 sin 60. Similarly, this T2, this is an angle 30 according to given figure. So this tension is also one kind of force. It is also resolved into two components. So it is nothing but 2 cos 30, and this is what? T2 sin 30. Okay, because the body is at rest. Okay, by seeing it is the body is at rest. There is no vertical and horizontal motion. That means what? Vertical forces is balances by the downward forces. Horizontal forces are balanced to each other. So from this diagram, okay, from free body diagram, we can write T1 cos 60 is equal to what? T1 cos 60 is equal to T2 cos 30. So T1 into cos 60, what is the value? 1 by 2 is equal to 2T into what? Cos 30 is equal to what? Root 3 by 2. So this is cancelled. That implies T1 by T2 is equal to what? Root 3. This is equation 1. Okay. Now compare vertical forces. Okay, what is that? T1 sin 60, T2 sin 30, both are acting on upward. Weight is acting downward. So the upward force balances the downward force. That means what? T1 sin 60 plus T2 sin 30 is equal to what? M into G. Isn't it? So you can write T1 sin 60 is equal to what? Root 3 by 2. Okay, plus T2 into sin 30 is equal to what? 1 by 2 is equal to what? Mg. Isn't it? So from this you can write T2 is equal to what? T1 by root 3. isn't it? So T2 is replaced by T1 by root 3. So it may write root 3 into T1 by 2 plus T2 is equal to what? T1 by root 3. That means what? T2 is equal to T1 by, what is that? 2 root 3. Isn't it? Equal to what? Mg. Okay, that implies you can write 2 root 3 is common. So root 3 into root 3. 3 into T1. That means 3 T1 plus T1 is equal to what? Mass of the body is given 1 kg, already given. What is the mass of the body? The body of mass 1 kg. Okay, into G already given. What is that? This is taken as 10. So 1 into 10. That implies 4 T1 by 4 T1. Okay, is equal to 4 T1 is equal to what? 20 root 3. 20 root 3. That implies T1 is equal to what? 20 root 3 by 4. What is the value? 5 root 3. So you get T1 is equal to what? 5 root 3. But T2 is equal to what? And T2 is equal to what? T1 by root 3. T1 is equal to what? T1 is equal to what? 5 root 3. 5 root 3 by root 3. Cancel 5. Isn't it? Okay, this is the answer for this question. What is asking? Find the T1 and T2. From that you get 4 T1 is equal to 20 root 3. T1 is equal to 20 root 3 by 4. That means what? 5 root 3. Okay, and T2 is equal to what? 5. So this is the answer. Okay, right. The fifth question. The moment of inertia of circular ring of mass m and diameter r about a tangential axis lying in the plane of the ring is. Here to see. What is that? The moment of inertia of a circular ring of mass m and diameter r. That means what? Given diameter of the ring. Diameter is equal to what? R. That implies radius of the ring is equal to what? Diameter by 2. Diameter by 2 is equal to what? R by 2 is the radius of the given ring. Okay, radius of the given ring. Okay. Now you want to calculate, he is asking what is the moment of inertia of this circular ring, okay, of mass m and diameter, that means radius is equal to what? R by 2. This is the radius of the given circular ring. Okay. About the tangential axis. About the tangential axis which lies in a plane of the ring is. This is the, okay, moment of, about this axis, what is the moment of inertia of this circular ring? Okay. You know one thing. If you know the moment of inertia of this circular ring about its center of mass, okay, and multiply the total mass of the ring and perpendicular distance between these two parallel axes, that gives rise to the moment of inertia of this circular ring about this tangent. That is nothing but parallel axis theorem. So from parallel axis theorem, okay, what is that? The moment of inertia of this circular ring about a tangential axis, say called I, okay, E is equal to sum of moment of inertia of the circular ring about an axis passing through its center of mass and mass of the ring and square of the perpendicular distance. Square of the perpendicular distance between these two parallel axes. So I is equal to what? Ig is equal to what? M r square by 2 plus total mass into m r square. Here to see m into r is equal to what? Radius of the given circular ring is equal to r by 2. That means what? R by 2 whole square by 2 plus m into r by 2 whole square. So what is this value? M into r square by 8 plus m into r square by 4. Okay, so what is that? 3mr square by 8. So this is the answer for this question. Okay, the sixth question. A satellite of mass 1000 kg is launched to revolve around the earth. Suppose this is an earth. Okay, okay, you want to revolve a satellite, then you should launch this satellite around the earth. This is radius r. This is height above the h surface of the earth. The satellite is revolved. So what is the total height of the satellite from the surface with respect to center of mass r plus h height? Okay, you know very well the required orbital velocity provided by the centripetal force, that means gravitation force. So from that you can say velocity of revolving satellite around the Earth in its orbit V0 is equal to whatever gm by r plus h. Now he is asking, okay, kinetic energy. So kinetic energy of orbiting satellite is equal to what? Half into m into v0 square equal to what? Half into m into gm by r plus h. So the answer is equal to what? G m by 2 into r plus h. This is the kinetic energy of orbiting satellite around the Earth. So kinetic energy is equal to what? G. Already G is given in the question. What is that? 6.67 into 10 power minus 11. This is called universal gravitational constant. What is the mass of the Earth? Mass of the Earth is given. What is that? 6 into 10 power 24 kg. 6 into 10 power 24 kg into m. M is the mass of the satellite. Is equal to what? 1000 kg. Okay, by 2 into what is the radius of the Earth? Radius of the Earth is also given. What is that? 6.4 into 10 power 6 plus h. H is equal. What is the height of the satellite above the surface? It is revolved. 270 kilometers. What? 270 into 10 cube meter. So all are now in SI unit. So you get the answer is 6.67 into 10 power minus 10 cube is 27. 10 power 27 minus 11 27 10 cube 27 minus 11. What is that? 16, isn't it? By 2 into 6.4 into 64. That means what? 270 plus 6.4. That means 276.4 into 276.4 into what is the value? 10 power 9, isn't it? 10 power 9. Not required. Yeah, this is nothing but not says to this way. So the value is 10 power 6. That means when you go into 2 into 6.4 into 10 power 6 plus 2.7 into 10 power 4 10 power 3. Okay, so finally get simplify this answer. 200 to 3 are approximately 27 plus 64 100. So 3 into 10 power I think 11. When you subtract this one, then kinetic energy is, so this is the kinetic energy of the 10 power 16, 10 power 6, that means minus 11 joule. Okay, this is the answer for this question. To the seventh question, the length of light string is 1.4 meter when the tension on it is 5 Newton. Okay, if the tension is increases to 7 Newton, the length of the string is 1.5 meter. The original length of the string is, that suppose this is a string here. Okay, you want to produce a tension by allow some amount of weight, okay, added to its free end. So what happens? Some elongation is produced, okay, compared to initial length, isn't it? So what is elongation? Final minus initial. So the elongation depends on what? Tension produced. That means the tension force is directly proportional to change in length. So T is equal to what? Some constant K into what? L minus L naught, isn't it? So here, when tension is equal to what? 5 Newton. Okay, what is the value? K is the spring constant. Okay, into the length is equal to what? 1.4 meter. But you don't know the initial length. So it is nothing but L naught. Now, if the tension is increases to 7 Newton, initially 5, now it is 7. On the same string, so spring constant does not change. Force constant does not change. Minus into, now what happened? Its length is increases to 1.56 compared to its initial length. So what happened? This is equation 1, this is equation 2. Now equation 1 is divided by equation 2. These two are cancelled. then 5 by 7 is equal to 1.4 minus L naught by 1.56 minus L naught. So 5 into 1.56 minus L naught is equal to 7 into 1.4 minus L naught. Okay, when you simplify this equation, you got it is nothing but 7.8 minus 5 L naught is equal to 9.8 minus 7 L naught. That implies this brought it inside, this brought it inside. That means what? Minus 5 L naught plus 7 L naught is equal to 9.8 minus 7.8. So 2 L naught is equal to 2. That implies L naught is equal to what? 1 meter. So this is the answer for this question. Okay, the 8th question. A wheel of radius, this is a wheel of radius 0.2 meter. Radius is what? Given. Radius of the wheel R is equal to what? 0.2 meter. Rotate freely about its center. This wheel is rotate about its center. Okay, when a string that is wrapped over its rim. When a string is wrapped over its rim, is pulled by a force of, when you pull this string which is wrapped over the rim of this wheel, it is rotate freely about an axis suspended from this ceiling with a force what? F is equal to what? 10 Newton. When you pull this string with this force, the wheel is rotate, okay, about an axis. Okay, established torque produced an angular acceleration of, which produces an angular acceleration of 2 radians per second. So this is the acceleration produced in this rotating wheel by applying a force of 10 Newton. Okay, 10 Newton. Okay, the moment of inertia of the wheel is I is equal to what? He is asking. You know, when the string is pulled down, the wheel start rotate about an axis. So this force produces angular acceleration. So torque is equal to what? I into alpha. You know, torque is equal to I into alpha. Okay, but torque is equal to what? R bar cross F bar. Why? Because this is the force F is applied at a perpendicular distance R. So torque is equal to what? R into F. Okay, is equal to what? From according to given, R bar cross F bar is equal to what? I into alpha. Okay, from this one you can get the required I value, because in this given question find the moment of inertia. So I is equal to what? R into F by alpha. Here what is the R? R is 0.2 meter radius of the wheel. Okay, F force that should be applied on the string is equal to what? 10 by what is the angular acceleration? 2 radians per second. So it is what? 1 kg. What is that? Meter square. So this is the moment of inertia of this rotating wheel. Okay. Okay, the 9th question. 2 water drops, each of radius r, coalesces to form a bigger drop. If T is the surface tension, the surface energy released in this process is, you see, there are 2 water drops. Suppose this is the first water drop, this is the second water drop, the radius are same. Okay, now these 2 are correlated, that means combined. So they form a bigger water drop. Okay, generally 2 water drops, okay, having surface area is equal to what? 4 pi r square. Okay, now these 2 are form a bigger drop, then change takes place in its, what is that? Surface area. Okay, you know, surface tension T is equal to what? Force, normal force acting per unit length, unit imaginary length on a free surface of a liquid. Now, due to my facility, I would like to take, okay, multiplied by L and divide by L also. So you get force into length is nothing but a work by what? L square. That means what? Work by what is that? Area. So the work is equal to what? Surface tension into area. Okay, why? Because the work done is numerically equal to surface tension when area is equal to what? Unit meter square. So work done to change in surface area while 2 small water drops to form a bigger water drop, the work is stored in the form of what? Energy. That is energy you are supposed to be collecting. That is asked. The surface energy is, okay, the surface energy. So surface energy, work is equal to what? Energy. So the required energy, that means energy, okay, that should be required to combine or to release to when big drop into small drop is same. So energy, that means surface energy is equal to what? Surface tension into what? Area. Okay, so T into what? Delta F. So T into 4 pi r square minus 4 pi small r square. Okay, right, that means what? 4 pi T into r square minus r square. So this is the required energy equation for this question. Okay, right. The 10th question to see, identify the characteristics of an adiabatic process in monoatomic gas. What are maybe the gas? Okay, need not to worry about that. For adiabatic process, adiabatic process. What is adiabatic process? Okay, the process in which the system, there is a change in, there is a physical changes in a system. Nothing is allowed to enter into a system. Similarly, nothing is allowed to leaving the system. That means here, system and surroundings in between only heat is supposed to be exchanged. That means what? In adiabatic process, there is no exchange of heat between system and surroundings. So dq is equal to what? 0. So from first law of thermodynamics, dq is equal to what? du plus dw. That implies what? 0 is equal to what? du plus dw. That implies du is equal to what? Minus dw. That means what? Internal energy is not constant. It is wrong. Internal energy is change. Okay, internal energy is what? Change. Okay, next, work done in the process is equal to change in internal energy. Yes, work done in the process is equal to change in internal energy. Next, the product of temperature and volume is constant. So what is the adiabatic relation between temperature and volume? T into V power gamma minus 1 is equal to constant, but not T into V is not constant. It is also not correct. The next, the product of pressure and volume is constant. So what is the adiabatic relation between pressure and volume? P into V power gamma is equal to constant. Here, gamma is equal to what? Ratio of specific heats of gas, Cp by Cv. So this is also not correct. Next, the work done to change the temperature from T1 to T2 is proportional to T2 minus T1. The work done, okay, in thermodynamic, that means adiabatic process is equal to N into Cv into delta T. That means what? N into Cv into T2 minus T1. Yes, the work done is to change the temperature from T1 to T2 is proportional to this much. So work done is proportional to what? T2 minus T1. So it is correct. So B and option E both are the correct for this question. Okay, right. For the 11th question, the internal energy of air in 4 meter into 3 meter sized room at 1 atmospheric pressure will be, okay, consider air as diatomic molecule. Okay, for diatomic molecule, okay, the internal energy du is equal to what? 5 by 2 N into R into T. If N is not given, so 5 by 2 RT, N is equal to 1 mole, then you can say D is equal to 5 by 2 RT. Okay, from ideal gas equation, PV is equal to what? RT. Okay, you can write PV, that means what? This RT is replaced by PV. Therefore, du is equal to what? 5 by 2 P into V. So this is the, okay, energy of a diatomic molecule. Okay, so here pressure is given. What is that? 1 atmosphere, 1 atm equal to 1.01 into 10 power 5 Pascal. Volume of the room, what is that? 4 meter into 3 meter. That means what? 12 meter square. Okay, so the internal energy, therefore du is equal to 5 by 2 of pressure equal to what? Simply you can write 10 power 5 only. Why? Because approximately equal to 10 power 5 Pascal into volume equal to what? 12. So 2 1 ja, 2 6 ja, 30. 10 power 5. That means what? 12 into 10 power 6 joule. Okay, so this is the answer for this question. 5 by 2, what is that? 5 by 2 RT. Okay, energy of diatomic, sorry, N is equal to 3 also is there, yeah. Into 3, volume into 3. N is equal to diatomic, N is equal to 3, then you get the answer is 12 into 10 power 6. 12 into what? 10 power 6. Okay, alright. Okay, that's it. So this is a 12 into 10 power 6 is the answer for this question. Okay, right.